Okay, welcome back everybody. Let's get back to set theory and talk about how to use inversion when we want to manipulate a set class. So inversion, another basic operation like transposition. Transposition. And let's also say invert around the zero axis, and I will show you what I mean by that. So let's start with the the first pitch that we'll look at our B flat, E, A, and E flat, right? So B flat is here, that's 10, A, E, and E flat. So when we invert around the zero axis, this is actually pretty straightforward. I'll switch colors to show you what I mean. We invert around the zero axis, meaning, let me change again actually. Come on now. Let's say we invert around, well, I don't want to cover up the number. Let's say we invert around this axis. And then, let's pick another more pleasing color. How about green? So when we invert around this axis, I think you'll like how straightforward this is. 3 and 9 are in symmetrically opposite places, so 3 becomes 9. 4 around this axis becomes 8. So 4 to 8. 9, every blue one is going to get a green one, right? So there's 3, there's 4. 9 becomes 3, so 9 and 3 are in what we call inversionally symmetrical. 10 is going to become 2. So just to make clear what I'm saying there, inversional symmetry notes that stay the same when they invert. So in this case, 9 and 3 were both in the previous set, and so they're both going to be in the inverted version of the set. So it's sort of like we're just like turning the piece of paper upside down on itself, like so that the front page is now facing down on a table. Does that make sense? So anyway, that's one way to think about inversion. And of course, if we go, oops, not there. If we go here, we can see we started with, we started with 10, 4, 9, and 3. When we submit them, if we do nothing but invert it, then we get 2, 3, 8, 9, which is what we got here. 2, 3, 8, and 9. And T0I is to show that we inverted it, but we transposed it by 0. In other words, we didn't transpose it at all. So let's also think about this. You can have both transposition and inversion at the same time. In other words, you would have T, and then we show it with an X, and then I. X is the number, the interval by which you're transposing, right? With X being the interval of transposition. So if we were to do that, then the set class stays the same. Like it's still going to be 0, 1, 6, 7 no matter what version of that we do to it. It's just going to be a different set of pitches. But they will still belong to that same set class. Let's say you had this operation, T, and then 2, and then I, like that. You had that set of things. That means that you have, you invert and then you transpose. Here you have you have the inversion, then you transpose it up 2 half steps. So let's do that with 3, 4, 9, 10 where we started. We inverted it already. Let me put that down here. We started with 3, 4, 9, 10. That was in its normal form, but not its prime form, which is 0, 1, 6, 7. That's the same for all of them, so that's not kind of the most interesting thing at this point. So 3, 4, 9, 10. We inverted it and got 2, 3, 8, 9, right? Which is that's this set of green lines up here. Then transpose it up 2 half steps, or 1 whole step, right? So that means that everything would move 2 half steps. So 2 would move to 4, 3 would move to 5, etc. If you kind of like thinking spatially, then I encourage you to draw one of these out and move stuff around on it. We'd already inverted it. We got 2, 3, 8, and 9. If I add 2 to each of those, then I get altogether 2 and 2 is 4, 3 and 2 is 5, 8 and 2 is 10, 9 and 2 is 11. Oops. 4, 5, 10, 11. So that's actually our next, that's how you would express that relationship. 3, 4, 9, 10 is where we started. Actually, so that's what I need to put here. 3, 4, 9, T. We inverted it to get 2, 3, 8, 9, and then we added 2 to get 4, 5, 10, 11. So if we start with this, and we do T2I, then we get 4, 5, 10, 11. And so that's, again, a way to express the relationships between these two sets that belong to the same set class. So I think it's good to do that first by hand, and then to demonstrate that you've done it correctly by just double checking with that set theory calculator. But I find it to be really helpful and save time to use that calculator instead of just trying to do it all by hand, and especially not being sure. I really like it as a way to kind of double check myself, and because then you can say here, like, I want all of these notes to count, I'm just going to put them right in with the keyboard, and I don't have to think about the intervals until later. You could also then take a look at the next little block. And let's put that one in and just see. We've got G sharp, 2, G, 11. It's good to double check yourself. G sharp, D, G, and not B, but C sharp. And now we can see that we have another 0, 1, 6, 7. And if we take a look at the last one, so notice that we're going to have a series of 0, 1, 6, 7, which can be a really useful thing to show. If you were to, again, like write about this, you could say like the piece begins with a series of, what's this word, like rolled statements of 0, 1, 6, 7, the set class. Let's check this one. F sharp, C, F, B natural. And there's 0, 1, 6, 7 again. What do you notice about that one and the downbeat? Aha, they are actually the same exact set, not just the same set class. So we could say this one is, we said there's a T10 relationship here. From C down to B flat is one way to look at that. From B flat down to G sharp also is a T10 relationship. So we do that again. And then from G sharp down to F sharp. So now I have more to say than just to say that it's a series of 0 and 6 sevens. I can say that they are each related by T10. And that's more sophisticated than saying like, well, there's some dissonant clusters in the first bar on each beat. And then notice that you can actually just keep going all the way down here into the second percussionist's line on the vibraphone. And you might find, for example, in a piece, if you're doing a larger analysis, that like maybe T10 is kind of like an important structural aspect of this piece. Like maybe a lot of stuff is related by T10, or maybe 0 and 6 7 is a big part of this piece, or maybe just the tritone from that set class is a big part of this piece. I don't want you to just think of these tools as like things to do just for their own sake. It should be part of some kind of larger statement that you're making about the piece. Like, well, if the tritone is an important aspect of it, then why? How does that fit in with the content of Amazing Grace, the original song? How does it relate to other pieces in the cycle? Like there should be some kind of larger point that you're making, not just labeling stuff the way that, we often do kind of as an initial step.